Hello everyone, welcome to section 6.4. We're going to talk about factoring using special forms this time, and there are three basic special forms that we're going to use. Just using a difference of two squares as shown on this page. We're going to talk about being able to factor using a perfect square trinomial, and I'll show you those, and being able to factor using a sum or difference of two cubes. And we're also going to look at another special form, which is essentially the quadratic form, and I'll talk about that as we go. So let's start. We talk about a difference of two squares. There are certain polynomials that always follow this same pattern as shown right here. Whenever we have a difference of two squares, what we're really talking about is the idea that we have two terms that are factored. Whenever we look at these two terms, this difference of two squares, we've got a squared minus a square. The difference can be factored as the square root of the first term minus the square root of the second term times the square root of the first term plus the square root of the second term. Now, how does this work? Well, in this particular case, what that means is that let's take a look at this guy. Our first form, how does this fit the pattern? Well, we'll note that the first term is the square of 6t. How do I know? Well, we can write it out. We can say, well, 6t, if we were to square that, we would get 36t squared. The second term is the square of 7r. So 7r squared would give you 49 times r squared. So using our form right here, we can see that this looks like we should be getting 6t, the first term, minus 7r, the second term, and another binomial with 6t plus 7 times r as the second term. As you can see, we could probably check this by going through and doing a direct factorization or direct multiplication. If you wanted to use the FOIL method, certainly you could. 6t times 6t is that 36t squared that we started out with as our first term, but then we take 6t times 7r would be plus 42 times t times r, and the second term would be minus 42 times t times r, and in the last term we'd have minus 49r squared. And you'll notice that the reason that this always comes out the way that we said it would was because we always have these two middle terms that will cancel out by addition. They are additive inverses of one another, and so we end up with 36t squared minus 49r squared as our result. Okay, so let's take a look at this next one. Well, it kind of looks like it's a perfect difference between two perfect squares, except that there's an extra factor right here, and that's the thing. If there is a common factor, we should always make sure that our first job is to factor out that common factor. And if we factor out y, we're left with the quantity x squared minus 16. And we'll note that both x squared and 16 are perfect squares inasmuch as x squared is x times x, and 16 is 4 squared. So using our format above, this is going to be the same thing as x minus 4 times x plus 4. But we had this extra factor of y, so we just leave it in front like this, and this is our complete factorization of x squared y minus 16y. Okay, you try it. There's one at the bottom right here for you guys to work out. I'll give you the answer in the next video.